We are recording. So number 5 from the quiz. So they give you a couple of roots and they want to know how to get the cubic polynomial. So they told us that -1 was a solution and plus or minus rad2 were solutions. And so what you do is you set, for these to be solutions, and that means x is equal to -1 as a solution, x is equal to positive rad2, and x is equal to negative rad2. And then what you would do is set each of these guys equal to 0. So adding 1 will give you x plus 1 equals 0, and then x minus rad2 equals 0, and x plus rad2 equals 0. And then so these, what we just did was we made factors, and then we multiply the factors. Multiply them. So that's what we were looking for, was to use the 3 roots to make 3 factors and then multiply. And so you would get it by doing x plus 1 and x minus rad2 and times x plus rad2. And those are all set equal to 0. The sum product rule is what we would use on this guy, or even better yet, the fact that they're the difference of 2 squares. You would end up with x squared minus rad2 squared, which is just 2. And then when you multiply all of those out, then it becomes x cubed plus x squared minus 2x and minus 2 equals 0. And that was the equation. You got to make sure if they're asking you for an equation, you should have an equal sign in your answer. 14 from the quiz. It's kind of involved. I would rather do one of the ones from the review worksheets. But here's what went wrong with, at least for my students for quiz 14, using the definition of a square. You need, a square has 4 congruent sides and 4 right angles. And so you needed to use the distance formula, and you needed to use the slope formula. And slope. And so you're drawing, when you draw a square, I would definitely use the origin as one of the vertices, and then we use the fact that if I go A, B, C, D, then this point is, if I call it A comma 0, this guy would be 0, 0, and then B would be 0 comma A, and then point C would be A comma A. These guys are related. And then you just use the distance formula for each of the sides. You needed to, find side AB and use the distance formula, and you would have ended up with 0 squared plus A squared, and it would have ended up giving you A. I'm not going to go through all the rest of them. Hopefully you guys will ask me ones from the review worksheets, because this one was quite involved, but you had to find all 4 sides, and you ended up getting that all of them were the same. And then you also had to find the slope of each of the sides. Find the slope of AB, and that would have been, you would have gotten like A over 0, so that's undefined. And then you needed to find the slope of BC, and that would have given you 0 over A, which is 0, and these 2 guys are perpendicular. And so you had to find you had to continue on finding the slopes of all of those. And then, of course, don't forget your English conclusion of, since the 4 sides are perpendicular and congruent, then I guess I was supposed to use SQRE. SQRE was a square. Number 10 on review number 2. this is review worksheet number 2, and then, but it's number 10. So this is review worksheet number 2, but then number 10 from it. It says the height in feet of a ball thrown into the air is given by this equation. S is equal to negative 16t squared plus 96t plus 112. And they want to know where, and then they say t is time in seconds, and find the max height. So we want to find max height. So the maximum height occurs at the vertex. Max height occurs at the vertex. And it's the y part of the vertex. Will always give your max or your min value, or your max or your min height. And so we need to find the vertex. So first of all, the x part of the vertex, or the t part of the vertex in this case, is negative b over 2a, where b is 96, and then a is negative 16. And what's 96 divided by 32? That's going to give you a positive 3. So then, so that means your vertex is 3 comma what? You plug it in. Plug it into your equation to get the y part. And so your s would equal negative 16 times 3 quantity squared plus 96 times 3 plus 112. And that's going to give you 256. That is going to be your max height. So the max height is always the y part of the vertex, so 256, and then they told us s was in feet, so feet. Ball goes up to a height of 256 feet, and then comes back down. Okay, and then number 8 and 10 from the quiz. Yes. Quiz number 8 is y equals 216x cubed plus 64. And they want us to find all of the exact solutions. So that means you need to set this guy equal to 0. So replace the y with the 0. And then I noticed that 8 is in common to both of these. If you didn't notice that, these are already the sum of 2 cubes. But what I noticed is 8 goes into that one 27 times. And 8 goes into 64 8 times. So then we still have the sum of 2 cubes. So if you didn't notice that, that would be okay. Just what's going to happen is you'll have more to factor out. And then this is the song, which isn't really a song. It's just a chant little thing, but guarantee you on the test you're going to have that. All right, so you take the cube root of the first and the cube root of the second with the sign in the middle. Then square the first, change the sign, multiply it together, and square the last. And the last one's always positive. Okay, so here's the deal with this. This guy here, you will always, always, always need to do quadratic formula on it. It will never factor, because I'm going to tell you right now, you're going to get 2 imaginary roots from that guy right there. So we've got 3x plus 2 equals 0, which will give you your one real root of x equals negative 2/3. And then here you've got to use quadratic formula, which is there was a negative boy who couldn't decide yes or no whether or not to go to a radical party. Turns out the boy is a total square because he missed out on 4 awesome chicks. Hopefully I can tell the difference between my 9s and my 4s over here. Okay, and the party was all over at 2 a.m. All right, so that ends up giving you that x is equal to 6 plus or minus the square root of, that becomes a negative 108. And then over 18. And then 108 is 36 times 3. And so you get a 6 plus or minus 6i rad 3. And then I had a lot of students cancel this wrong, so highly recommend that you factor out what is in common to the top, which is a 6, so that you see that you are left with a 1. Let's rewrite that because that looks messy. When you factor out the 6, don't forget that there is a, come on. When you factor out the 6, there is a 1 plus or minus I rad 3. And then over 18. And then, of course, the 6 goes into the 18 3 times. So your answer is negative 2/3, and then 1 plus or minus I rad 3 all over 3, since 6 goes into 18 3 times. Fundamental theorem of algebra says that I should have 3 answers. Since my biggest exponent is a 3, I should have 3 answers. And sure enough, I've got 1, 2, 3 right there. All right, so that was that one. And then number 10 from the quiz. Okay. Which is 12x to the 4th plus 17x squared equals 5. All right, so your first step on these when you go to solve is to set it equal to 0. So you need an equation set equal to 0 before you start solving. So we're going to subtract the 5 and set it equal to 0. I saw this factored. The problem is that I don't have the work to show me the other way, but that's okay. So I saw this factored. It factors like a quadratic. And so I like to use heart replacement. And so this is like 12. Okay, so here, let me say this. Heart is going to equal x squared, which means heart squared would be x squared squared, which is x to the 4th. So this, I can rewrite this like 12 heart squared plus 17 times heart minus 5 equals 0. And then how does that factor? Do I really want to show you all of this work? I guess I'm going to. Hopefully we're nicer to you on the test with nicer numbers, but 2 numbers that multiply to negative 60 but add to 17 are a positive 20 and a negative 3. So I'm going to rewrite the middle term as a positive 20 heart and a negative 3 heart, because 20 heart minus 3 heart will give you 17 heart. And then you factor by grouping. What's in common to that? A 4 and a heart, which will leave you with a 3 heart plus 5. And then you factor what the second 2 have in common, which is nothing but a negative. So I'm going to factor out a negative 1 and be left with 3 heart plus 5. Your parentheses match, so that's one of your factors. And then the other one comes from 4 heart minus 1, those guys right there. All right, so I like to use hearts because I know math does not have hearts in it. And so right now I know to go back and replace the hearts. Once I get it factored, I'm going to replace it back with 3x squared plus 5 and times 4x squared minus 1. At this point, it should be where if you were to multiply these back out, I'm not going to do that because that would be going back to the original problem, but you should get the original problem if you were to FOIL these out. First times first will give you 12x to the fourth. Outer and outer is a minus 3x squared. Inner and inner is a plus 20x squared, and then a minus 5. So you know we're right. Setting each of these factors equal to 0 gives you an x squared equals negative 5/3. And this one would give you an x squared equals positive 1/4. And when you take the square root of both sides, don't forget, taking the square root of x squared leaves you with a plus or minus the square root of negative 5/3. And you're going to pull out the negative. You are also going to rationalize it. So it's like a rad 5 over rad 3. And then to rationalize, I'll multiply top and bottom by rad 3. And then that'll give you a plus or minus I rad 15 over a whole 3. So there's one of your answers. And then x squared equals 1/4. That means x will give you a plus or minus the square root of 1/4, which is 1/2. And so I've got 1, 2 answers there, and I've got 3, 4. I've got 2 more answers there, and so 4 answers, which is what I should have for an x to the 4th. All right. Number 7 from review number 1. So review worksheet 1, and I'm doing number 7 from it. Okay, which is f of x is 3x squared plus 30x minus 4, and they want you to put it in the form, in vertex form. So you got to complete the square to do this. Complete the square to get it to vertex form. So the first thing I'll do is replace the f of x with a y, because that's the same thing. And then I'm also going to add the constant over to the y side. So add 4, I'm going to leave a little space. Before you complete the square, you can't have a number on the x squared, so I'm going to factor it out. So I factor out the 3, and I'm going to factor out the 3 from the 30x, which leaves me with a 10x, and leave a little space. And then when you go to complete the square, you take the middle term, the b term, right, so 10, and you cut it in half, and you square it, which is 5 squared, which is 25. So that's what I'm going to add here, is 25. But what I really added to the right-hand side was 3 times the 25. So I really added 75. So that's what I'm going to add to the left-hand side. And then I clean it up, and it's y plus 79 is equal to 3 times a perfect binomial square. And where you get this from is this number right here. The b over 2 is what goes here, so x plus 5. And then your last step would be to subtract over the 79. So it's 3 times x plus 5 quantity squared minus 79. And then we started with an f of x, so you really use f of x equals instead of y. And that's your answer. All right. Okay, so that was 7 from review 1. Number 9 from review 2. Danielle, is the minimum the y part of the vertex 2? Yes, because a parabola will either have, a parabola opening down, your vertex is a max. And if the parabola is opening up, then your vertex is a minimum. So you won't have a max and a min, you'll have one or the other, and it happens at the vertex, and it depends on if the parabola is opening up or down. If you remember, if it opens down, that means that you have A is negative. You'll have a negative in front, and when it opens up, then your A is a positive number in front there. And so yes, you find the maximum or the minimum the exact same way, and that's by finding the vertex, and it's always the y part of the vertex. Okay, number 9 on review 2. We did one like this in the notes also, but they want you to find the maximum perimeter of the rectangle that can be drawn under the curve. So that is an opening down parabola. Y equals 24 minus x squared is your equation, and they want it so that the rectangle's base is on the x-axis. So I'll just draw some random rectangle. It's inscribed, so that means that the top part of the top side of the rectangle is actually hitting the sides of the parabola. I know a parabola 24 minus x squared is a opening down one, where right here is going to be 24. So that's your y-intercept. And then what you're going to do is say that this point right here is x. So this little section, let's redo that. So what I'm saying is that this value right here is going to be x from the origin to the side of my rectangle. What that means for you is that this point here on the rectangle up top, you have x as your x coordinate, and then that point totally coincides with the parabola. So the y part is the 24 minus x squared. That's what that point is. And we want the perimeter of a rectangle, and what we know is the perimeter. You'll have to have this memorized because we won't give it to you. It's equal to 2 times the length plus 2 times the width, where the width of your rectangle and the length. So the width, I'll say, is this guy. I'll call it my width, which means that it's x plus x, or 2x. And then I'll call this guy my length, and that y value is 24 minus x squared. And so we plug those in. So the perimeter will be 2 times 24 minus x squared and plus 2 times 2x. And then that'll give you a 48 minus 2x squared plus 4x. And so if I rewrite this, that means the perimeter is negative 2x squared plus 4x plus 48. And we want the maximum perimeter, and the max happens at the vertex of this parabola. So of the perimeter, notice that the perimeter's equation, if I were to graph the perimeter's equation, it would be a parabola. And so we want the vertex of this part. We want the y part of the vertex of this perimeter equation. And so if I find the x part first, that would be negative b over 2a, which would be negative 4 over 2 times negative 2. So that gives you a positive 1. And then you plug that in. So the max perimeter will be negative 2 times 1 quantity squared plus 4 times 1, and then plus 48. And so that gives you 50. So the max perimeter would be, that's the max perimeter. All right. So that was 9 on review 1. on review 2. Okay, so I got that one. Told you about the minimum part. 15 on review 2. All right. Okay, so it says a communication signal on a straight path from the top of a transmitting tower located at, they gave us -625. And then, so the signal travels on a straight path from the top of the tower located at this point to a receiving dish located at 411. So these two make up a line, because it's saying that the signal travels from the top of the transmitting tower located at the first point, and it goes to a receiving dish located at the second point. And then, so what do they want? They want, so it's like, I don't know, something like that, right? There's some communication signal going from this point to this one. And then it says that there's an antenna located at 9.5. So 9.5. So I don't know. Whatever. Okay, so the signal, whatever. Okay. We'll just put a point, 9.5. Oh, because I put it wrong. Dang it. That's my issue. Ugh. Pooper scooper. It's a good thing that I looked at that again. I'm going to trash those. Trash. 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 Okay. -6, -25, and then 411. Thanks, Cassia. You can always count on you too. Find things. Okay, so -6, -25 to 411. That makes way more sense. I was like, man, the point is like way off. -6, -25. Okay, so here's this transmitting signal, and then there's some other point, some antenna at the point 9.5. And we want the distance. So remember, the distance is always going to be that perpendicular distance. And then you have to have that distance formula memorized. For the distance from a point to a line is going to be ax1 plus by1 plus c all over the square root of a squared plus b squared. So what we got to do first is find the equation of the line. So for the line, you need to find the slope first, right? So the slope would be -25 minus 11 over -6 minus 4, which is what? -36 over 10, which 2 goes into both, so what? -18 over 5. Well, no, something's wrong. Negative over a negative, so it'll be positive, and it's positive 18 over 5. And then it'll be, choose one of the points, doesn't matter which one. If I go with y minus 11 equals 18 over 5 times x minus 4, then that leaves me with, you need to get it in standard form, right? Or you need, it's not a huge deal if you have fractions, but it's probably better to just do it. So let's get rid of the fraction. Let's go with 5y minus 55. I multiplied both sides by 5 to give me 18, and then I'll distribute x minus, what's 18 times 4? 72, I believe. Yeah. Okay, so then that's a 18x minus 5y minus negative 72 minus negative 72 plus 55 would give me a negative 17 equals 0. Yeah, okay. Nobody's typing anything, so hopefully I didn't make an error there. All right, so that means A is 18, B is negative 5, and C is negative 17. And then the 9, 5 is your x1, y1. They're going to plug in. All right, so we've got the distance is equal to absolute value of, that would be 18 times 9 plus negative 5 times 5, and then plus a negative 17, all over square root of 18 squared plus negative 5 squared. These are so not friendly. Come on, 2, and then there is an absolute value sign over here. All right, so then that should end up giving you 120 over rad 349. If there's no errors there. And what did it say? Round to the nearest hundredth. So you're going to actually put that in your calculator. And we say that it is 6.42. That's to the hundredth. Hundredth place means 2 decimal places. Did they give us any units? They did not. So there we go. That's your answer. So that was 15 on review 2. We want to do 16 from review 1. Okay. So this is review 1, number 16, which is prove the diagonals of a rectangle are congruent. So diagonals of a rectangle are congruent. All right, so we're going to start off by drawing a picture. And what we know about a rectangle is opposite sides are congruent, right? So did they want us to, they didn't name it, so I'll just call it ABCD. I'm not creative, so whatever. Okay, and then A I put at the origin, so that point is 0, 0. D, I'll call it A, 0. And then what you need to know about a rectangle is the sides are not the same, right? So for point B, it's on the y-axis, so its ordered pair is 0, and then I can't use A. If I used A, that would mean it's a square. Instead, I'll use B. And then point C is totally related to these, to point B and D, in that it has the same x value, so A will be its x value and B will be its y value. And then we want to prove that AC is congruent to BD. We want to prove AC is congruent to BD. So you got to use the distance formula. And so let's find AC. This is the square root of A minus 0 squared plus B minus 0 squared, which is the square root of A squared plus B squared. Stop. Don't you dare keep on going. This does not simplify anymore. Does not simplify at all. If you think it does, here's what I keep showing my students. Let me go to it. Here's what you want to do. Is A squared plus B squared, you guys want to say that it's equal to A plus B. And it's not. I'll give you one example of where it's not. You know the perfect 3, 4, 5 Pythagorean triple, right? So if A is 3 and B is 4, is it equal to 3 plus 4? Heck no. This is 9 plus 16, which is rad 25. We know that that should be a 5, which is definitely not equal to 7. So don't you dare. Once you get to the square root of a squared plus b squared, you better stop. It does not simplify anymore with just variables. Okay? So don't do it. Don't lose points because you did everything right, but then you simplified the square root of a squared plus b squared incorrectly. Okay, so let me go back to it. All right, here we go. Okay, so AC is the square root of a squared plus b squared. We are now going to find the length of BD, which is the square root of, that would be a minus 0 squared plus 0 minus b squared, which is the square root of a squared plus negative b. Quantity squared is a positive b squared. And so you get the same values. Don't simplify. And then you say since AC was congruent to BD, which was square root of a squared plus b squared, the diagonals, so this is your English conclusion. Don't lose points because you don't write the English conclusion. The diagonals of a rectangle are congruent. Yay! All right. So that was 16 from review 1. You want 16 from review 2. Review 2, number 16, is proving the diagonals of a square are congruent. Okay, so the only difference, we're going to do it exactly the same way, but the only difference is now it's a square. Did they call it anything? No. Okay, so I'll call it A, B, C, D. All right, so here's my square. So the difference is for a square, you've got all of the sides are congruent, or yeah, all the sides are the same. So I'll call it 0, 0, A, 0, B will be 0, comma A, and C will be A, comma A. And then we're going to prove AC is congruent to BD. So AC is the square root of A minus 0 squared plus A minus 0 squared, which gives you a square root of A squared plus A squared, which is 2A squared. So the A can come out and leave you with A rad 2. And then BD would be the square root of A minus 0 quantity squared plus 0 minus A quantity squared, which still ends up with A squared plus A squared, which is 2A squared, which is A rad 2. And so these guys are equal. And so since AC is congruent to BD, which is A rad 2, the diagonals of a square are congruent. Okay. What if 4A squared plus 4B squared was another square root? Would that simplify? Yes. Go back to this. Because of the 4. So 4A squared plus 4B squared. what you would do is factor out the 4 that's in common to the 2. And that's the same thing as saying the square root of 4 times the square root of a squared plus b squared. And so you would pull out the 2 because there's a perfect square in there. Like that. So that's just a side note there of yes, yes. It's just because that 4 is a perfect square. If it was any other number that's not a perfect square, then you wouldn't be able to. I mean, you could, it would just still be a rad. So what's the point? Okay. All right, let me go back to that real quick while I look to see what other question. Okay, so that was the diagonals of a square were congruent. That was 16 from review 2. Okay, so now we got number 3 from the quiz. Okay. So we give you this graph, and it looks something. Nope. I don't know, something like that. And they give us certain points. One of them was 4, -3. They give us, but then we can look at the fact that yeah, I did a horrible job of plotting this, but whatever. Okay, so I can look and count boxes to find that the vertex is at 2, -5. And, okay, and that's actually enough for me to show you that what you see is the equation for a parabola is y equals a times x minus h quantity squared plus k, where the vertex is your h comma k. And so I know y is equal to, there might be some a value there, but x minus 2 quantity squared, and then minus 5. And now what I need to do is figure out what's a. I like to count boxes. So the normally a parabola from the vertex would go right 1 up 1 and right 2 up 4. And what we notice here is that they went right 2 up 2. They went right 2 up 2. Where normal would be up 4. So the normal parabola, the parent parabola, would have been right 2 up 4. And how do you go from 4 and getting 2? You would multiply it by 1/2. And so that's why it's an a is 1/2 there in front. Your a value is 1/2 because from the vertex we went right 2 up 2 instead of right 2 up 4. And you get that by multiplying your y values by 1/2. Now if you hate that, well, I think that's the easiest personally, but another way is you've got y equals a, plug in your vertex, you got x minus 2 quantity squared and then minus 5, and then choose a point. I would choose the one we gave you, 4, 3, and plug that into x comma y and solve for a. So -3 in for y and a 4 into x. And then you can solve for a. So I would add the 5 over and get 2 is equal to a times 4 minus 2 is 2, and 2 squared is 4. And when you divide both sides by the 4, you get a is 1/2. So it's just another way for you to be able to find the a value. I think it's easier to count boxes, but you do have to know that a normal parabola would be right 2 up 4. So Okay. Number 7 on page 111. Just because we only have 10 minutes left, I want to make sure to do the review worksheets over something that the 2-7, number 6. Yeah. Okay, and I'm going to skip your questions, and if we have time at the end, I will come back to them. I want to make sure that we do all the questions from I told my students, I'll tell all of you, what you want to study is the group quiz, review worksheet 1, and review worksheet 2, and you will, it's like, here you go, here's the test, right? The numbers changed, obviously, but. Okay, review number 2, number 14. All right. So this is review 2, number 14. Tells you to find all of the solutions of 8x cubed minus 27. So this is the song, because it's the difference of 2 cubes. And you take the cube root of the first, which would be 2x, and the cube root of the second, which is 3, with the sign in the middle, the minus sign. Then, so that means start a new parenthesis, square the first. Now when you're talking about squaring the first, I'm now looking at what's inside these parentheses. So it's the 2x squared I'm going to square, which would give you 4x squared. Change the sign, so now this will be a plus sign. Multiply together, 2x times 3 gives you 6x, and then square the last, and the last one's always positive. All right. Remember what I said on this. This guy will never factor. Never. I know it looks like it's going to. It took me a long time to figure out this guy is never, ever, ever going to factor. You are never going to find two numbers that multiply to 36 and add to 6. It's not going to happen. You are going to get two imaginary solutions from that factor right there when you do the sum or difference of 2 cubes. Whenever you do the song, you're going to get one real root. That's this one. X is 3/2. And then the other factor that you get from the song, you got to do quadratic formula on it, and your answers are going to be imaginary. So we got negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that ends up giving you a negative 6 plus or minus the square root of 36 minus blah blah. That should be negative 108 because I already did one just like this. Yeah. Negative 108 all over 8. And then, 108 is 36 times 3. So you got a negative 6 plus or minus the square root, nope, go back, of 6i rad 3 all over 8. All right, so now what you got to do is factor out, oh, see, so the thing must have been a little bit different than this. Oh yeah, because the things were switched. Yeah. Okay. All right, so what's in common? We can, a 2, right? So I'll factor out the 2 that's in common. I know there's a 6 in common, but you're still going to, like, only a 2 will cancel with the 8. Yeah. Okay, so I'm going to factor out the 2 that I'll be able to cancel in the bottom. And I'll leave you with a negative 3 plus or minus 3i rad 3 all over 8. This 2 will cancel with this 8 and be a 4. And so you've got 3/2 as one answer, and then negative 3 plus or minus 3i rad 3 all over 4, which is 2 more answers. My equation was a cubic, an x to the third, so I should have 3 answers, and I got them. So yay. All right. Worksheet number 2, number 12. So they want you to solve 3x cubed plus 2x squared minus 9x minus 6 equals 0. Whenever I see 4 terms, then I think, let me see if I can factor it by grouping. So looking at the first 2 terms, what do they have in common? An x squared, so that we would be left with 3x plus 2. And then you look at the second 2 terms and see what they have in common. And that is, what, a negative 3? Yep. Because your goal is to get your parentheses to match. And so do you see doopy-doop and doopy-doop? Parentheses match, that means that's one of the factors. And then the other one, when you factor out the parentheses, so when you factor out the 3x plus 2 that's in common to both of them, you're going to be left with x squared minus 3 as your other factor. So we've got 3x plus 2 as one factor, and the other one is x squared minus 3. Set each of these factors equal to 0, which will give you an x is negative 2 over 3, and then this one would be x squared is 3, which will give you x is equal to, don't forget, plus or minus the square root of 3. So 1, 2, and 3 answers. Yep. All right, any other questions from the review worksheets or from the quiz? And if there's not, I'll go and answer Anna's questions from the page. But if you have any questions from the review worksheets, let's do, okay, nobody asked one of these, so let's do this. Because it wasn't on your quiz. I want to make sure you guys practice it. Oh, and that one too. Okay, so, and that one too. Okay, what time do we have? All right. We got time. Okay, so don't forget, let's do review 1. Review worksheet 1, I'm going to do number 3. So we got x minus 2 rad x equals 15. So remember, the first thing you want to do is set it equal to 0. So x minus 2 rad x minus 15 equals 0. This looks exactly like, a quadratic. It's not a quadratic because it doesn't have an x squared, but it looks the same way as x squared minus 2 times x minus 15 equals 0. Because if my middle variable is a rad x, when you square it, it'll give you x. Square root of x squared would be x. And so it factors exactly the same as this guy. 2 numbers that multiply to negative 15 but add to negative 3 would be a negative 5 and a positive 3. And so it factors the same way, except that since your middle term is a rad x instead of an x, it's going to be the square root of x and the square root of x. But then it's still going to be minus 5 and plus 3. And then you set each factor equal to 0 and solve So you get rad x is 5. Squaring both sides will give you x is 25. And then this guy, rad x, is -3. This is the principal square root, and so that's not going to happen. You're going to throw out that one. The other thing you could do is, if you solved it and you got x is 9, you want to make sure you plug it in, because if you plug it in, it will not work. 9 minus 2 times rad 9, is that equal to 15? Definitely not, because that would be 9 minus 2 times 3 is 6. Definitely not equal to 15, so we throw that guy out. And so your answer is just 25, which should make sense because it's an x to the power of 1, and so you should have one answer. Okay, and then I also want to make sure nobody has asked anything about nature of the roots. So don't forget, this is review worksheet 2. Numbers 5 and 6. Don't forget nature of the roots, because this was not on the quiz, but yet it's on the test. So nature of the roots, you're going to use the discriminant, b squared minus 4ac. And if it's less than 0, you'll have 2 imaginary complex conjugate roots. And then if the discriminant is a positive number, then you have 2 unequal real roots. These are all roots. And then if it's equal to 0, then you could say either that there's 2 equal real roots, or another way to say it is 1 double root. The other way to say that is it's got a multiplicity of 2 is, what is happening with that one. So make sure you know that's for the nature of the roots. Doing numbers 5 and 6, it's literally a b squared minus 4ac, and figuring out, and then you got to name what it is. And then I also, before time is out, I want to do something like 7 and 8 from the review, because that also was not on the quiz. So numbers 7 to 8, you want to find the equation given roots, right? So these are one easier than the other. Not really. They're both about the same. Okay, so I'll do number 7, which says if 1 minus 3i is a 0, then find the quadratic equation, right? So what you got to remember is if 1 minus 3i is a 0, then that means its conjugate is also a 0. 1 plus 3i is also a 0. So now you have 2 zeros, or 2 roots. A 0 is a root as a solution. So now you've got 2 of them. The easiest way to handle this is to use the sum product rule, which is x squared minus the sum of the 2 roots times x, and then plus the product of the 2 roots. And so you find the sum. That would be adding them together. If you add these 2 guys together, the 3 i's cancel, and you're just left with 2. The product, what's nice is you're multiplying conjugates. And so what you end up having is the first guy squared minus the second guy squared. So 1 squared minus 3i quantity squared, which is a 1 minus 9i squared. And if you remember, I squared is -1. This ends up giving you a 1 plus 9, which is 10. And so plugging that in, your quadratic equation, don't forget your equal 0, will be x squared minus the sum times x plus the product. equals 0. Don't forget the equal 0. Don't lose points because we ask you for an equation and they don't, and you don't give us an equal 0. Okay, I feel satisfied that I went over things that were not on the quiz that you're going to be responsible for. And yeah, what's it called when the discriminant is positive? 2 unequal real. All right, guys. Looks like time is up. I'm going to stop the recording. I'm going to put the link to the recording in this little chat window right now. So if you came in late and you want to rewind and watch it from right now, then you can right away. And then I'm going to upload it onto YouTube, and I will send out a text to you guys when the YouTube version is on there. But all of you are in Adobe Connect right now, so you could just watch the video right now. But anyway, you're all very welcome. And I'm going to stop the recording.